Hello students, in third lecture we discuss the mesh analysis. Today in this lecture we will discuss the nodal analysis. It is the another method to solve the network. Clear? That is, you will see nodal analysis. Nodal analysis. As you know, the mesh analysis depends on the KVL, while the nodal analysis depends on KCL. Clear? What is this? This is the KCL and the Kirchhoff current law. Clear? You see, we are drawing a circuit. Say this is the E1, this is the R1. This is R2, this is R3. Here is source, say this is the E2, this is the R4 and this is R5. Clear? Now we have to find the current in all resistances with the help of nodal analysis. Clear? You will see there are the few steps which will followed in the nodal analysis. First of all, we select the principal node, clear, and the node where the three or more branches meets. Now you will see this is the node 1, this is the node 1. How many branches are meeting? 1, 2, 3. Say this is the 1. Second node, it is this is the node 2. Here also the 3 branches are meeting. And here the 1, 2, 3, 4, and this is the 4th node. Clear? That means there are the 3 nodes. Clear? Out of this, so first of all, we will select the principal node. Second, now we take or mark the reference node. Mark the reference node or zero potential node. Clear? And the reference node or the potential node is that particular node where the maximum number of branch meets. Clear? Otherwise we can take any of node as a reference node, but we favor that the reference node is taken when we are taking the 3 or more branches. Clear? So here the node 1 3 branches, node 2 3 branches, and the node 3, that is the 4 branches, and it is taken as the reference node and the mark like the earth sign. Clear? And this is the zero potential node. Clear? Now we will mark the current through each resistances. Say this is the I1, this is the I2, and say this is the I3, this is the I4, and this is the I5. Clear? This is the I5. You can take any direction. Clear? But remember that if we are taking the wrong direction, clear, the answer will become negative. Clear? Now you will see this is the I1, I2, I3, I4 and I5. Now how many nodes are there? There are the 3 nodes. Clear? Now we will write the 2 equations. That means if there are the n nodes, then the equation will be n minus 1. Clear? Now you will see, take the potential of this node 1 V1 and the node 2 that is the V2. Clear? Now we will put the value of the I1, I2, I3, I4 and I5. You will see what is the I1? That is the current always goes from the high potential to low potential. Here the potential is E1, here the V1. That means the what is the E1? That is the E1 minus V1 upon R1. Clear? Similarly, what is the I2? The current is going from node 1 to node 2. That means the I2 it is equal to the V1 minus V2 upon R2. And what is the I3? Clear? Now the I3 is going from E2 to V2. That means the E2 minus V2 upon R3. Clear? Now what is the I4? Clear? Here the potential is V1. This is the zero potential. That means what is the I4? That is equal to the V1 minus 0 upon R4, and the I5 that is equal to the V2 upon R5. Clear? It is the first set of calculation. That is the value of the I1, I2, I3, I4 and I5. Clear? Now we apply the KCL. Clear? Now we are using the KCL. You will see at node 1 apply KCL. Apply KCL. Now you will see what is the incoming current I1. Clear? Outgoing current I2 and I4. That is the I1 is equal to the I2 plus I4. Clear? Now we will put the value of the I1, I2 and I4 from this set of the equation. What is the I1? That is equal to the E1 minus V1 upon R1. That is equal to the I2. It is the V1 minus V2 upon R2 plus E2 minus I4. What is the value of the I4? That is the V1 upon R4. After solving this, we are getting an equation in V1 and V2. Now we will apply KCL. Apply KCL at node 2. Clear? Now when we are applying the KCL at node 2, you will see the incoming current I2 and I3, outgoing current I5, that is the I2 plus I3, that is equal to the I5. What is the value of the I2? Please, that is the V1 minus V2 upon R2. What is the value of the I3? That is the E2 minus V2 upon R3. And what is the value of the I5? That is equal to the V2 upon R5. Clear? Now you will see we are getting the equation 1 and equation 2. Clear? After solving the equation 1 and 2, we will get the value of V1 and V2. V1 and V2. Clear? Now when we find the value of the V1 and V2, then we will put the value of the V1, V2 in this set of equation of the current, and we will get the value of the I1, I2, I3, I4, I5. Now we will solve this numerical with the help of nodal analysis. We have to find the current in each resistance with the help of nodal analysis. You know that what is the first step? First of all, we will choose the principal nodes. Principal nodes, that is where the 3 or more branches meets. This is the node 1. This is the node 2. This is the node 3, and this is the node 4. You will see here the 4 branches are meeting, here the 3 branches are meeting, here the 4 branches are meeting. But at node 4 there are the 1, 2, 3, 4, 5, it is the reference node. Clear? That means when it is taken as a reference node, it will shown like this, and this is called the reference node. Clear? Reference node or zero potential node. Clear? Now you will see in this there are the two current sources. This is 10 ampere and this is of 2 ampere. You will see in this branch I1, I2, I3, I4, I5, I6 and so on. Now the number of nodes are 4, then we will make the n minus 1 equation. Clear? Say the voltage of this node, that is the V1, voltage at this node, say V2, and the voltage at this is the V3. Now we will write the equations. See, what is the I1? Clear? I1, that is the V1 minus V3. The 5 ohm is connected in between node 1 and node 3, that is the V1 minus V3. Clear? So V1 minus V3 upon 5. What is the value of the I2? Clear? The I2 is flowing in between node 1 and 2, that is the V1 minus V2 upon 3. What is the I3? I3, clear? V1 and the reference node, that is equal to the V1 minus 0. 0 why? Because it is the reference node or the zero potential node upon 2. What is the I4? Clear? I4 is flowing from node 2 node 3, that is the V2 minus V3 upon 1 ohm. 1. Clear? Now what is the I5? I5, it is flowing node 2 reference node, that is the V2 upon 5. V2 minus 0 upon 5. And what is the I6? I6 is flowing from node 3 to reference node, that is equal to the V3 minus 0 upon 4. Clear? Now we have to apply the KCL at node 1, node 2 and node 3. Clear? At node 1. At node 1. Clear? You will write the incoming current is 10 ampere. That is the I. It is equal to the I1 plus I2 plus I3. What is the value of the I? That is the 10. So you can write here this is the I. Clear? I, that is equal to 10. What is the value of the I1? V1 to V3. That is the V1 minus V3 upon 5 plus I2, that is the V1 minus V2 upon 3. V1 minus V2 upon 3 plus I3, that is the V1 to reference node, that is the V1 upon 2. V1 upon 2. After solving this, you are getting the first equation, 31 V1 minus 10 V2 minus 6 V3 is equal to 300. Clear? Now the at node 2. At node 2. Clear? At node 2. What is the incoming current? I2. What is the outgoing current? I4 and I5. Clear? That means now we will apply the KCL at node 2. That is the I2 is equal to the I4 plus I5. Clear? I2 incoming, I4 and I5, it is the outgoing, that is the I2, it is equal to the I4 plus I5. Put the value of the I2, I4 and I5 from this set of equation of the current. I2, that is equal to the V1 minus V2 upon 3, that is equal to the I4 V2 minus V3 upon 1 plus I5, that is the V2 upon 5. Clear? After solving this equation, we are again getting the equation 5V1 minus 23V2 plus 15V3 is equal to 0. Clear? Now at node 3. at node 3, again we will apply the KCL. Now you will see at node 3, what is the incoming current? I1. I1 is incoming, I4 is incoming. So that is the I1 plus I4, that is equal to the I6 plus 2. यहाँ पर कितना करंट आ रहा है, बाहर निकल रहा है 2 एम्पियर, that is the outgoing current is 2 ampere. Then the I1 plus I4 is equal to I6 plus I2. Now we will put the value of the I1, I4 and I6. Clear? Now what is the value of the I1? That is the V1 minus V3 upon 5 plus I4, that is the V2 minus V3 upon 1, I6, that is the V3 upon 4 plus 2. After solving this equation, clear? Now we are getting the equation 3. Now you will see we have the 3 unknown and 3 equations. Now after solving these 3 equations with the help of the calculator, we will get the value of the V1, V2 and V3. अब जितने भी unknown थे उनकी वैल्यू आ गई हमारे पास. Now you can put the value of the V1 and V3. You will get the value of the I1. You will get the value of the I2. Putting the value of the V1, V2 upon 3. And after repeating these process, putting the different value of the V1, V2, V3, you are getting the value of the I1, I2, I3, I4, I5 and I6. Clear? Now we will solve another example using the voltage sources. Clear? In last numerical, we solved the network having the 2 current sources. Here in this, we are considering the 3 voltage sources, 100 volt, 50 volt and 50 volt. Clear? Basically, in examination, the question it is the find the value of the Ix and Iy using the nodal analysis. Clear? If you see, it can be solved with the help of the mesh analysis. But when the examiner says that you have to solve this problem with the help of nodal analysis, that means we have to apply the nodal analysis. Clear? Now we will follow some steps of the node analysis. First of all, we will select the node. This is the node 1. This is the node 2 and this is the node 3. How many branches are meeting? 1, 2, 3. At node 2, 1, 2, 3. But at the node 3, there are the 4 branches. 1, 2, 3, 4. That means we will take in this is the reference node. Clear? That means we will apply the KCL in the node 1 and node 2. Clear? As I told you that if there are the n node, we will make the n minus 1 equation. Clear? That means here we will make the 2 equation. Clear? Now say the voltage of the node 1 is V1 and the node 2 is V2. Clear? Now we will write the set of current equations. Then what is the I1? You will see 100 V1, that is the 100 minus V1 upon 10. What is the value of the I2? Clear? That is the V1. Clear? Plus minus plus, that means this is the V1 plus 50 minus V2 upon 2. Clear? What is the value of the Ix? What is the value of the Ix? V1 and the reference node, that is the V1 minus 0 upon 5. What is the I3? Clear? I3. Here you will see negative to positive. Here again negative to positive. Clear? Then what you will write? That is the V2 plus 50. Clear? What is this? This is the V2 plus 50 upon, resistance is 3. Now what is the Iy? You will see the Iy is flowing from reference to the node V2. Clear? That means here the current flowing from the higher potential to low potential, that is the 0 minus V2 upon 2. Clear? Now we will make these set of equations I1, I2, Ix, I3 and Iy. Clear? Now apply KCL at node 1. At node 1. Clear? At node 1 we will apply the KCL. What is the KCL? Incoming current is equal to outgoing current. What is the incoming current? I1. Clear? What is the outgoing current? I2 plus Ix. Clear? Put the value of the I1, that is the 100 minus V1 upon 10, that is equal to I2 V1 plus 50 minus V2 upon 2 plus what is the Ix? That is the V1 upon 5. What Ix? That is the V1 upon 5. After solving this equation, clear? You will get this equation, that is the 8V1 minus 5V2, that is equal to the minus 50. 8V1 minus 5V2, that is equal to the minus 150. Clear? Now we will apply KCL. Apply KCL at node 2. Clear? When you are applying the KCL node 2, then what is the incoming current? I2. Clear? Plus Iy is also incoming. Clear? At this node, Ix is outgoing. For this node, incoming is I2, outgoing is Iy. Then what is the Iy? That is the I2 plus Iy, that is equal to the I3. I2 V1 upon 5. Clear? What is the value of the I2? That is the V1 plus 50 minus V2 upon 2. What is the Iy? Minus V2 upon 2. And what is the value of the I3? That is the V2 plus 50 upon 3. V1 plus 50 minus V2 upon 2 plus minus V1 by 2 is equal to the V2 plus 50 upon 3. That means you are getting this equation, 3V1 minus 8V2 is equal to minus 50. Clear? After solving these two equations, you are getting the voltage value of V1 and V2. So V1, that is the minus 19.38, V2, that is equal to the minus 1.02 volt. Clear? Now you will see, you have to find the value of the Ix. What is the value of the Ix? That is the V1 upon 5. Ix, that is the V1 upon 5, that is equal to the minus 19.38 upon 5. Clear? And what is the Iy? That is equal to the minus V2 upon 2. And what is the value of the V2? That is the minus 1.02 upon 2, that is equal to the 0.51 ampere. Clear? Now you will see we are calculating the value of the Ix and Iy with the help of nodal analysis. Clear it? Now you will see that we have calculated the Ix and Iy with the help of nodal analysis. Clear? This is the very important question asked in the different universities, questions like the UPTU, Haryana Technical University, Rajasthan Technical University. In all, it is a very important question that we have to find the Ix and Iy with the help of nodal analysis. Clear? It is. Now we are concluding this lecture 4, and in lecture 5, in the next lecture, we will discuss the super mesh and super node. Clear? Now in lecture 3 and lecture 4, we did not discuss the super mesh, we did not discuss the super node, but in the next lecture we will solve the problem where we are using the super mesh and super node. Clear? If you have any doubt, you can write in the comment box. Clear? or email on my the ID.